Good morning. Welcome to the Securing Containers at the Edge with Falco session. My name is Loris De Giovanni. I'm the founder and CTO of SysDig. Today, we're going to talk about a little bit about runtime security at the edge, and in particular about an open source runtime security tool called Falco. I'm personally involved with Falco, so I'm going to essentially bring the perspective of one of the creators and maintainers of the tool. But let's start from the high level. So clearly, we have a new stack that is forming. Traditionally, we had our applications that were run on servers, on data centers. Relatively recently, around 10 years ago, we started moving to the cloud and started using essentially paradigms, that are becoming more and more widespread, like CI/CD, like reserving instances, like orchestration, and so on. And clearly, nowadays, we are looking to adopt the modern way, let's call it cloud-centric way, cloud-native way of deploying applications, and bring it to the edge, and being able to adopt these paradigms also when we write software and when we run software for IoT and applications that are running on devices that sit at the edge. And clearly, there's like a lingua franca, a common denominator that is appearing to run applications in these heterogeneous environments, and essentially being able to adopt the same approaches and treat things in a similar way. And this common lingua franca is clearly becoming Kubernetes. Kubernetes in its data center incarnations, and Kubernetes in its edge incarnations like K3s, for example. Why Kubernetes is becoming essentially the standard platform that we're adopting to write applications that then can be orchestrated and can run everywhere? Well, there are many reasons, but some of them are Kubernetes is horizontal. Again, it's becoming a platform that you can use to run in a similar way your software in different places and still take advantage of the common denominator. It's rich and powerful. It's standard as a way to run software, so that I don't know, even when we're sitting in the cloud, instead of taking advantage of functionality and APIs that are unique for the specific cloud vendor, we can leverage something that is more like common. And this is important, especially when there's fragmentation and differences in the cloud. And it's extremely interesting and cool when actually the cloud vendors start offering essentially their interface based on Kubernetes, because nowadays every cloud vendor is offering their own Kubernetes flavor. And that's a trend, in my opinion, toward unifying essentially the APIs and the approach to the different clouds. This means that, Kubernetes is vendor independent and developed in a way that you can run your software everywhere, but also in a way that is driven by a community and not by a specific vendor. And, open is, of course, the most important feature. It's really, I've been doing open source my whole life. In particular, my first company was called Case Technology and was the company behind the Wireshark network analyzer. So I've been doing open source for more than 20 years. And it's interesting to see how the previous generations of open source were sort of emulating something that was developed initially as closed proprietary technology, right? The databases, MySQL, that was the open source version of the SQL databases, or even Wireshark, which was a network analyzer that was mimicking initially the commercial network analyzers. While in this wave, Kubernetes is really the innovation engine, and the whole innovation is starting open and is starting community driven. And this is very powerful. And in my opinion, is really one of the most powerful and incredible things that Kubernetes is bringing to the world, everywhere, and to the edge as well. So everything is wonderful, everything is great. Well, actually, no, right? There's always challenges. In particular, these new world is very powerful, especially when you think about applying, containers and orchestration to the edge. And it has a revolutionary nature in what you can do. But at the same time, it increases complexity, right? Containers, which are a great way to isolate applications and workloads, also tend to be opaque and tend to reduce the visibility and control in terms of what you can see for your applications. Microservices definitely generate complexity and potentially increase the attack surface. Um, Containers uh, tend to have a short lifespan. We released a survey, a statistic that shows that the vast majority of containers in our user base, in our customer base, last for less than 5 minutes. Actually, many of them last for less than 10 seconds. It's very hard from the security point of view to get the right forensics and incident response when the unit of your workload is such a short lifespan. And it's also hard to troubleshoot your applications when the unit is so short-lived. So many advantages, but also some issue to take into account when using the more sophisticated technologies to deploy edge applications. Security in particular is where I'm personally focused on, and security definitely brings challenges in this new world. Um, every time you increase the complexity, from one point of view, it's nice because you can use some features from the security point of view that are better included in the platform, in particular in Kubernetes. But you also potentially increase the attack surface, and especially for devices that are running maybe far from your data center, far from your perimeter, and sometimes in situations where it's hard to keep track of them. So from the security point of view, I really think that the approach is changing. The approach is changing in the data center, but the approach is changing when we're orchestrating containers everywhere, including at the edge. Security more and more is based on the pipeline, right? On the CI/CD pipeline. I like to say, like presented in this slide, security is build, run, respond. Build phase means shifting security left, right? And being able to perform vulnerability scanning before your containers go into production, being able to trigger notifications and block builds when there are vulnerabilities like dependencies or pieces of code or libraries or something like that in your containers. And this is done typically by scanning your containers and plugging scanning of containers and code in as many places as possible in the CI/CD pipeline. And of course, you want to validate configuration and make sure that it's compliant before going into production. Then you have the run phase. So run is very important because especially in the edge, you have your applications running on your devices, and this is where they live, when they are in production, and this is where they are the targets of risks and attacks. So it's important to have a strategy for runtime security, for network security and segmentation, for visibility and monitoring. And then, of course, something can happen. And you are probably familiar with the challenges of understanding the blast radius of an attack, doing forensics, doing troubleshooting for something that is sitting at the edge. And this becomes even more critical when the edge is orchestrated and things can move or can go up and brought up and down very quickly by an orchestrator that takes these decisions based on automation and automatic rules. It's very important then when you craft your security strategy for your edge software, you take all of the three phases: build, run, and respond into account. And the beauty of Kubernetes is that the platform offers solutions for each of the different phases. In this talk specifically, I want to talk about the central part of this, the run phase, so runtime, so protecting and detecting your containers at runtime. And I want to talk about Falco, which is the de facto tool for runtime security in Kubernetes. What is Falco? Falco is a runtime security engine. It taps into the kernel of the operating system by leveraging facilities into of the Linux kernel, like eBPF, to be able to capture extremely granular information from every single node, from every single device, and every single container that is running on the device, and also from the Kubernetes orchestrator, and put this information together to let you know when something of interest, when something dangerous, when potentially an attack is happening. Falco is designed as a standalone tool, but it's also designed to be completely modular. It's heavily based on APIs to be integrated not only with Kubernetes, but with the rest of the ecosystem and the rest of the security stack that you will build based on essentially community-driven projects like Falco. So Falco is absolutely something that is used independently and can be used independently. But as I was saying before, it's part of a bigger build, run, response strategy, and covers essentially the run phase in the strategy. Use cases, examples of what you can do with Falco. Detect data tampering and theft. Very often, if somebody manages to get into one of the devices, there's a chance that the devices may be reconfigured, that traces are deleted, that data is exfiltrated and stolen, which can be very concerning. Falco is able to detect this kind of stuff and send you notifications for this. Identifying intrusions, so somebody breaking into one of your devices, pinpointing suspicious connections, or just attempts of connecting from or toward one of the devices, and potentially detecting misconfigurations that you might have left in these devices. I like to compare Falco to a security camera for containers and Kubernetes, which is sort of interesting since we're talking about edge devices like security cameras. It's almost like Falco is the security camera for your security cameras. But Falco essentially can sit on your devices, and you definitely, as I was saying before, want a complete strategy and want locks for your devices. You want to make sure that access is prevented. You make sure that there's a solid, the policy for passwords. You want to make sure that there's the correct authentication so that people cannot get inside your devices. But and that's equivalent to having good locks, for your house. But even if you have good locks, people can still get in. Maybe they can get in from the window, and so it's very important that there's constantly visibility through something equivalent to a security camera, so that when somebody's inside, you can know it and you can see what they're doing. And this is essentially what Falco does for Kubernetes orchestrated containers, and for example, in case of K3s, for edge orchestrated containers. Falco is a CNCF project. It's an incubated project. It went into incubation in 2019. I started the project together with other people in 2016, and we decided in 2018 to go to the CNCF route because first of all, we thought there was an important serious gap in security for Kubernetes, but also we strongly believe that a tool like Falco that is heavily based on contributions from the community and validation from the community in terms of rules and policies and so on really benefits from truly embraces the community, becoming a multi-vendor tool that is driven not by a single company, but is driven actually by a community that is validated by the CNCF. Architecturally, Falco is conceptually relatively simple. You have rules, you have an evaluation engine, you have input that is coming from a certain number of sources. As I was saying, kernel events, for example, system calls. So every time a file is open or read or written, every time a connection is established, every time data is transferred on the network, every time a user performs an action like executing a command or modifying a file or logging in and so on, every time something like that happens, a system call is generated and the kernel event is generated. Falco can listen by leveraging eBPF to these events, and each of these events super granular, like an open on a file, a connect toward a server on the network. These all become inputs that Falco is able to capture and process. Container metadata to make sense of these inputs so that you can reason essentially in terms of services, and you can understand not only that IP address A is talking to IP address B, but service A is talking to service B. The container metadata is used for that. Kubernetes audit events, so actions that are performed in Kubernetes. All of these go essentially in the evaluation engines, and thanks to the rules, it generates outputs that can go in different places: gRPC, webhooks, syslog, SDK. People send the output of Falco to SIEM tools to collect them and perform analysis. People send the output of Falco to decision engines like OPA to take further actions, for example, blocking stuff at the admission controller level and so on. And all of these essential integrations, I will have links at the end of the presentation, but we offer essentially ways to configure these and to have Falco tuned in the best possible way for your environment. Examples of rules that you can create with Falco. A shell is running a container. As you can see, the syntax of Falco is relatively simple and is designed essentially for compactness and to generate low entrance barrier in terms of learning the syntax. So if you're used to other policy engines, like for example the OPA one, OPA definitely optimizes for flexibility through their Rego language, while Falco optimizes a little bit more for simplicity. So it's easy for you to create rules that match specific patterns that you want to detect. So as you can see, shell is running a container. The rule is container.id different from host and process name equal bash. Override system binaries. This checks, the directory in the file descriptor and checks that we have a write action. Changes of container namespace. This would be a container in one of your devices that is trying to go and fetch information from a different containers, which is typically something that you don't want. Something written in /dev. Process trying to access the camera device, just examples, but as you can see, you have flexibility to essentially capture this granular event coming from the system and putting them into a relatively simple, logical Boolean operation that then essentially, when triggered, can generate in different forms an alert for you, an email, a Slack message, and so on. Okay, we've talked about Falco in a general way for the moment. Let's talk a little bit about what the Falco community is doing specifically for the edge. So 5 things here. Uh, One is we've been working recently in reducing the number of dependencies that Falco requires to be compiled and to run. This is important because we are really targeting making Falco binaries that are as small as possible, potentially sub 10 megabytes, so that they can be deployed also on devices that have extremely limited resources. So essentially, you can have Falco that is simple enough and small enough to really be deployed anywhere. Static builds is related to that. So not only Falcon needs to be small, but it needs to be completely self-contained. So the deployment becomes very natural, even on devices that maybe don't have a ton of sophistication in what you can deploy on top of them. And the kind of libraries and dependencies that you have there. So it's completely self-contained. Falco that is also small and doesn't depend on third-party libraries can really run on every device. Of course, every device also means that we need to be able to target the kind of processors and architectures and machines that are the ones that are common at the edge. So there is an ongoing effort to make Falco work on ARM. There's actually a working group that is being recently created to focus on Falco on the edge and Falco on ARM specifically. So if you're interested in that and you're interested in participating or just trying this, I recommend, this is the message that essentially starts the working group, and we're talking at least for a while on a regular basis to essentially make this work. Low overhead, another very important one. The Falco developers and community are really focusing on decreasing the footprint in terms of memory, in terms of CPU, and so on that Falco is using, so that it can run on tiny devices that are sitting, by themselves at the edge. And one thing that is interesting, also, we're looking at different ways of instrumenting. As I was saying, traditionally Falco is based on instrumenting the kernel of the operating system, but in some cases it might not be possible to get access to the kernel. And we currently also have a working group that is focused on being able in those situations to instrument a target container by using techniques like ptrace or stuff like that don't require the access to the kernel of the operating system. And so it's a little bit more general and a little bit less demanding in terms of instrumentation. All of this kind of stuff is actually current work in progress, but we've made good enough progress that I can actually show it to you. So let me switch to my console, and actually let me restart Falco here and take a look at the log. So here I actually am on a machine, as you can see, which is a ARM64. This one is actually running on AWS for this demo, but it's an ARM instance on AWS. By the way, yeah, it's pretty impressive how compared to your typical machine, just how many CPUs you can get on these architectures. This is actually, one of the standard ones that you get on AWS, and I'm running on 96 cores here. And I started, as you can see, Falco on this machine, and I actually have also K3s running on this machine. So as you can see, I can see the details of K3s running on this machine. So I have essentially my infrastructure and my architecture running here. And on this machine, Falco is running under the hood. Not a lot, that I need to worry about from that point of view, but you can immediately see that if I start doing something malicious on this machine, like let's, for example, simulate modifying a binary file. If somebody goes and modifies a binary file on your machine, it's typically pretty bad and evidence of an attack, you know. This is just an example of one of the many things that Falco can detect for you. And in fact, sure enough, you know, as soon as I've done that, on the other window, where I'm tailing the Falco logs, which in this simple setup are just writing to this machine. Of course, in your normal setup, you will want to ship them somewhere, but Falco is immediately telling me that a file below a binary directory has been opened for writing. So essentially, somebody's modifying something, some of my default binary files. It's telling me the command line and the file that is being modified. So essentially, I have the details and the information about this specific incident that then I can go, you know, collect and analyze later. Another thing that Falco can do, as I was saying before, is being able to consume Kubernetes audit log events and take those events and apply rules on top of that. For example, here, what I've tried to do is I tried to create a config map on my K3S deployment that includes AWS credential and AWS token in the config map. This is something that you should never do, essentially putting sensitive information in a Kubernetes config map. And Falco is able, by applying rules to the audit log, to intercept this and let you know exactly what happened, and let you know, this is not good, and also let you know exactly the details about what happened. So 2 examples of Falco from one point of view, looking at your machine specifically, and being able to look at deep information. For example, somebody modifying a binary file inside or outside the container, or Falco taking a look at your cluster and being able to let you know when something bad happens in your Kubernetes configuration or action or deployment and so on. Of course, Falco is a set of hundreds of rules. So these are just 2 examples of what Falco can do, but the general concept hopefully is clear. You know, again, you have a security camera, you have somebody taking a look at what's happening in your cluster, in your containers, in your application, in your devices, in your endpoints at runtime, and in real time being able to notify you when something bad is happening, when something is coming through the window, and letting you know what they're doing and what the consequences are. Almost done with my time. I just want to give you guys a couple of resources. This page contains a couple of blog posts that have been published recently and that will guide you specifically if you are interested in learning more on Falco, on K3S, and Falco on ARM specifically. So this is content that the Falco community has actually put out recently, and just go take a look and you can learn more. And my final thoughts are, yeah, the edge is becoming more and more powerful. With more power, you will have also the risk of more threats. Runtime security is not the only piece, but it's a key piece of your strategy. So you must make sure that you take care of runtime security when you run Kubernetes at the edge. As a consequence, you must use Falco. These are some links. We're very welcoming as a community. Please come, say hi, try Falco. Let us know what you think. Let us know if we can help you. And other than that, thank you very much for following this session, and let me know if there are any questions.